So, hello, thank you for joining. My name is Shimon Ben David, Chief Technology Officer for Weka IO. With me is Randy Kreiser, Storage Architect at Supermicro. And today we'd like to discuss the topic of things to consider when deploying GPUs. So, obviously, this is a very complicated and interesting topic, and we'd like to share from our experience, myself from the Weka side, and Randy managing and leading many projects from the Supermicro side. During this webinar, feel free to ask questions in the chat, and we'll answer, obviously, on the chat or verbally as we see them. So, presenting the topic. So we all know that have been many disruptive trends in technology, cloud environments, NVMe, SSD, flash technology, and GPU proliferating into the enterprises, as well as additional accelerators that are now being used or starting to be used in multiple environments. And all of these technologies actually enabled new trends and new use cases in multiple markets. So whether you're in the life science market, automotive, financial, research, media, and more, even in classic HPC. So GPUs and flash technology and cloud environments have been are growing and actually enable enterprises to do things that they couldn't have done before. What we see is that, and by the way, we'll cover a few of these use cases. What we also see is that according to a lot of CIOs, looking at the most desired technologies that they look to modernize in, accelerated compute takes a very important part. So as mentioned, that could be GPUs or DPUs or IPUs, and there's additional accelerators out there. But I think organizations understood the benefit of using these additional accelerators. As you can also see, by the way, not marked, but you can also see that there's obviously a stress on security, but also a lot of stress on the infrastructures that enable these accelerators in the environment. So I think we all understand now that just adding a GPU in an environment doesn't immediately solve a problem. The fact that it gives you more compute power doesn't immediately enable your process and provide your workflow. It needs to be added in a way that provides value, whether that's investing in infrastructure, investing in the data platform, the storage environment, and investing in the pipeline, in the orchestration of the environment. So we can see that additional technologies that are desired to be innovated on are, for example, solid state environments, solid state storage environment, scale out environments, and cloud technologies. So not surprising, but complementary to the accelerator workloads. What we did is we actually had a questionnaire sent to more than 500 organizations, and we asked them several questions. And I think this would be interesting to go over because they actually show us how organizations are currently using AI and ML and GPUs in general, as well as their plans on growing that. So what we see, as I mentioned, we send that questionnaire to more than 500 organizations. What we see is that we have more than 1,000 answers here. It actually means that some organizations have multiple use cases. So where do we see, what are the top use cases in AI according to that questionnaire from existing environments? So recommender systems, which are interesting. I think we're all familiar with them. This is kind of like your Netflix. What would be your next movie? What would be your next music song that you want to hear? So recommending you according to your specific criteria. Scientific visualization, image recognition. I think we're all familiar with that. Autonomous car environments, autonomous trucks environments, actually autonomous drones environments. So recognizing an image or a video and obviously taking a decision according to that. Compliance. Compliance is actually a big thing. We see compliance in many ways, and we'll talk about it more in the next slide. But In compliance, actually, we see a lot of financial environments that are heavily regulated, and they're using AI with compliance to automate the gathering of new compliance that they need to comply by, new regulations that they need to comply by, as well as verifying that they're constantly compliant, that there's no piece of information that they might get penalized on. Conversational AI, that's a very interesting use case, and a very, I think, one of the original use cases that we're familiar with. Cybersecurity, computational chemistry, and I would say transcoding is an interesting one. We actually went to that organization and actually dug a bit deeper into how they're using AI in transcoding, and it's actually a very interesting use case, because what they're doing is, first of all, they're using transcoding farms, and they're using AI to make sure that they optimize the workload across their transcoding farm. And also, when transcoding a film, actually AI enables them to choose specific areas to transcode, so then they're more efficient in how they're doing it, and how much capacity it takes. So the main thing here is to show that there are actually a lot of AI use cases in multiple organizations, and even in ways that we didn't necessarily think that exist. Additionally, what we see, we broke down that these 500 customers' answers into their market share. So what we see is that obviously within different markets, there are different stress on where AI would be mostly used. And again, this could be AI, ML, and other GPU workloads. So for example, in the healthcare industry, we see compliance is the main usage. Image recognition, scientific visualization, but compliance is a heavy thing, because dealing with customers' data, personal PII, personal information, and also in the banking and finance, again, unsurprisingly. In other environments, so for example, in government and research, scientific visualization is more important. In media and entertainment, obviously, sale and conversational are more dominant. So different markets would have their different use cases. The main thing to see here is that all markets are using it. And usually what we see is that if an organization doesn't use AI ML to get a leg up on his pipeline, on his insight from data, or on his activities, usually other organizations within the same market are using it to get that leg up. And here I'd like to pass the mic to Randy to talk about a few interesting AI projects that he's been working on.
Thank you, Shimon. So in history, there have been very few things that have added more data to analyze and so forth than GPUs. And here is, 10 different fields that, clearly add tons of data that need to be analyzed and things of that nature, in oil and gas and so forth. Smart city, talks about, or the types of projects that we have in smart city, where, cities will put up a couple thousand cameras. I worked on one at a large airport, international airport, and they want to put up 12,000 cameras to show everything that's going on in that area, and the analytics that would be used to do different aspects of what's happening and so forth is incredible. The amount of data coming in from 12,000 cameras, as you can imagine, is just an abundance of information. Government and defense, image recognition, things like that. How has the image changed over time? Things of that nature, all extremely important to national security and things of that nature. And those types of projects are just exploding with the amount of data and the resolution of that data with what GPU brings to the table. Autonomous driving in the automotive area and things. We've all seen where different companies want to do autonomous vehicles and things like that for simple things as simple as delivery of packages, delivery of pizzas. I mean, it's pretty incredible. The explosion of data in regards to that being real-time decision making and so forth is just an amazing thing. But it's across everything. It's across media and entertainment, as Shimon talked about, healthcare, things of that nature. When you go to the doctor, or you go to the to get an X-ray done or some type of image done, to be able to see exactly what's transpiring, in regards to a broken bone and how they need to resolve that, and the amount of data. If you go to get an image of something, they hand you a DVD on the way out now, and things of that nature, so that you have, all of this with you. So the amount of data, just incredible, and we need to be able to deal with it. Those are the types of use cases that I see on a daily basis.
Nice. So actually, I have two interesting topics here. With healthcare, one of the things that always it's a bit funny but interesting. So with healthcare, AI is not artificial intelligence. It's actually augmented intelligence, because you're not going to tell a doctor that an artificial intelligence can replace them, right? And we see actually some very interesting use case with medical segmentation, where a doctor is looking at the customer X-ray, and AI is now trying to segment bad cells and healthy cells. So that's very interesting. Additionally, in financial services, we see some very interesting use cases with the amounts of data. So Randy, you mentioned the amounts of data, and just to give some clarification on that, what we see is that modern financial environments take investment, for example, hedge funds, they would take investment decisions on multiple parameters, sometimes millions of parameters, and they gather data from anywhere, starting from media hubs, Reuters, and more, and also social media. So when trying to take an investment decision, they now want to account for all of the parameters that might affect that investment decision. And gathering terabytes of data for an investment decision is not unknown. So yes, data is exploding across these environments. Another insight is that what we're seeing is what was usually considered classic HPC environments in the amounts of data and cores that are being used to calculate and get to a decision is now growing into the enterprises. So enterprises that up until recently had large amount of data, but they didn't necessarily need to go over it in a near real-time fashion, such as HPC environments used to do, are now starting, or more than starting, are now already in that revolution and transformation where they do need to do that. An additional question that we asked our audience was, or our survey was the amount of expenditure on AI workloads. So we see that more than 50% are spending of the responders are using less than $1 million a year for their new AI initiative. And there's always a few in the middle, and then there's the big environments where they are spending more than 30 millions a year. So what that actually tells us is that a lot of organizations are only starting with their AI initiative to see how they can grow them. And I think one of the focuses that we want to emphasize here is that you want to make sure that as you start correctly, because there are ways to, obviously, your day one implementation. So for example, starting an AI initiative, investing in some form of GPU environments, whether it's a GPU server or a server with a GPU, can get you initially starting. And then there's the day two, day three. How would you grow your environment? There are different massive changes between your day one environment with a single GPU server. Then as you grow to 5 servers, 10 servers, do you grow worldwide? So there's a very, you want to make sure that as you start, you plan ahead. And we'll talk about some of the considerations of what do you need to consider as you grow, or as you will grow your environment. And by the way, obviously we're expecting next year's survey to reflect higher numbers, because we only see investment in AI growing. So an additional topic was, what was the biggest headwind environment? What was the most, what was the biggest challenge? in achieving your company AI goals. So you already started that way. And obviously, organizations that already went down that path and accumulated experience, what was the main challenge in achieving your AI goal? And interesting part was that the majority of them were saying too few data scientists. So we all think about AI investment in terms of how many servers do I need, what's the infrastructure, and more, and we'll talk about more. But the biggest challenge is how do you retain, how do you hire your data scientists? And actually, this is something that the human capital here, which is something not planned ahead for, is something that we're seeing in multiple environments. So for example, in financial environments, we see that one of the main challenges of is hiring quants that will make the trading decisions. So sometimes the soft skills here are also that important. And I would say that from experience and from talking with multiple customers, um, good people prefer to work in modern environments. So there's kind of like the chicken and the egg here. If you modernize your environment, people will come. If they come, you can modernize it further. So that's an important aspect that kind of like surprised us a bit, but it's interesting. Another important challenge that was faced, the environments faced, is data privacy issues, because depending on what market you're in, different privacy issues apply to you. For example, with medical information, there are different regulations in Europe and in the US. So how do you obfuscate the data? How do you work on the data while it's being obfuscated and you still manage to get some important insights? How do you retain the privacy? How do you comply with privacy? Additionally, insufficient technology infrastructure. So that's not surprising because we see companies and environments that are starting with the AI environment. As they grow, they need to grow their AI environment and not necessarily just plan it ahead. Budget, and then if I'm looking at lack of data, you could see that it's in the number 5 place. So actually organizations, I think if we did this survey 2 or 3 years ago, we saw lack of data as the number 1 problem. Environments, organizations had many challenges gathering data, whether it's buying the data or whether it's buying the models or whether it's accumulating the data from multiple sensors and then when storing it. And if you're familiar with the phrase, data is the new source code, because with AI and machine learning and also with deep learning, obviously, the more data you have, actually, the more accurate your model can be. So data was the king, I would say. We see that lack of data is actually not the biggest challenge nowadays. So that's very interesting. So I think whatever market you're in, it's really interesting. Before you plan for your AI environment, you want to think about where will you get your data? Will you accumulate it? Will you buy it from a broker? Is it already tagged? Is it already in the format that you need it to be? So there's a lot of data considerations there as well. An additional question that we asked was, what accelerators are you using? Because we all are familiar with GPUs, but by NVIDIA, then there's the AMD GPUs, there's Intel, there's other accelerators, IPUs, DPUs, different type of accelerators. So it's easy to see that currently NVIDIA are leading the market share in accelerators, with AMD and Intel behind. And there are like additional like a 4% of others. What we actually think is that over the upcoming year and next years, that will actually grow, because NVIDIA really piloted that market and they really did a great job at creating an infrastructure, whether that's the GPUs themselves or the servers that can accommodate for these massive amounts of CPUs and therefore of GPUs and therefore cores. And also they created a very convenient infrastructure around it. So for example, now Supermicro are offering NVIDIA-based servers with their HGX and EGX, also with their infrastructure around. So we see the NVIDIA market growing. We see other markets growing in addition, because other hardware vendors are also starting to pick up the pace, creating other hardware environments, and other frameworks around them, which are not, which are as important. Additionally, one of the questions that was really interesting for us was the networking environment, because having these massive servers that can compute massive amounts of data, as they should, actually creates a strain on how would you move the data around, which is one of the considerations. And we do see, again, in different markets, there are different innovation and different acceptance rates, but definitely we wanted to see how modern are customer networks. And we see that almost 50%, 45% of the environments are now already on 100 gig environments, whether it's Ethernet or InfiniBand, or even more, 200 gig. So that really shows that the market is planning to move. Is some of it is already in that infrastructure place where the infrastructure is ready for GPU environments, or it's growing there. And actually, obviously, we're expecting that to grow year over year. There's still the question of what framework will you use. So if in the past we used fiber channel or Ethernet or InfiniBand, and there were a few more that since disappeared, we do see Ethernet and InfiniBand now growing, and Ethernet actually even more. So, and obviously this is a call to action where if you want to, if you're just planning your AI environment, you want to make sure that you have sufficient networking in your environment and even in your servers to take out that data. So for example, we've seen GPU servers that are using 6 gigabytes per GPU. So imagine a server with 8 GPUs, you need 50 gigabytes per second almost. So that's actually, you want to make sure that that server isn't congested on a very thin pipe of networking, because otherwise you'll be limited in what that GPU can perform.
Shimon, let me add a point there. You make a great point in regards to network bandwidth and performance, and the previous slide talked about GPU servers. And it's obviously easy to, add one GPU to a server or two or even 4 or 8 or more. The key is being able to balance the network bandwidth with the amount of compute capability that you have in that GPU, and be able to handle that within that infrastructure that you're building. So it's important to pay attention to the things that maybe not everybody thinks about, such as network bandwidth, because today, with the advent of some of the fast storage technologies, which we'll talk about in a few minutes, the ability to push that data around now is going to be limited potentially by the network itself.
Yep, great point. Actually, teaser for the next topics is you also want to make sure that it will support modern GPU workloads with GPU direct storage and such, and we'll get to that. So in summary, and I want to summarize that part regarding the information that we just presented, which again, what is real information from 500 organizations that we talked with. So 93% of the organizations already have some form of AI initiative. So again, it's a call to action. If you're not doing that, probably your competitors are. AI is seen first as a way to generate competitive advantage. So we also asked them, by the way, that was what we presented here is only part of the questionnaire. Feel free to email us if you want us to send you the complete questionnaire. But we also, one of the questions was also, what are you using AI for? And we showed some use cases, but the majority eventually summarized it, we want to generate a competitive advantage. Data is no longer a limiter to AI initiative. We discussed that as well. That was in the number 5th place of which challenges do you have with your AI initiative. Number 1 was actually talent acquisition. Infrastructure, human infrastructure. NVIDIA is the major provider of GPU accelerated compute, but AMD and Intel are actually behind it. And there's actually more accelerators growing in the market. For example, Cerebrus is a big one. customers have aggressive plans to move to the cloud. So again, we didn't cover that in the, we have that in the complete questionnaire, but we also ask customers about their cloud initiatives. What are the cloud initiatives today and how do they plan to see it in the future? There's definitely an aggressive move to the cloud. And there's also, if discussing kind of like, how do you want to do it? Do you start with the cloud on day one? Is the cloud on day three? What we usually see is a lot of organizations start in the cloud as their day one implementation because it's very easy to set up. There's almost no expenditure. It's just OpEx. You just pay as you go. You shut it down when you don't need to. So it doesn't require a lot of investment. I think one of the focus point that we want to say here is um, as you start on the cloud, and then as you grow, possibly you go back on-prem because then it might make more economic sense, and then you burst to the cloud when needed. You want to make sure and you want to consider that your orchestration environment can accommodate for that. So what we see is that if not planned correctly, you might orchestrate your environment to a specific cloud environment, and then you have a lock-in. It's really hard to move from that place if you want to go to another cloud or if you want to go on-prem. So you want to make sure that as you plan your day one, day two, day three moves, even the orchestration around it can accommodate to moving around. And then there's multiple ways to do it. You want to make sure that your storage can accommodate, that your compute, your containerized environment, if you're using that, would accommodate for that. And there are already a lot of solutions that enables that. But this is something that you want to think about from day one and not just say, hey, I'm already 2 years into my cloud environment and I want to go back on-prem. Now I have a problem. It's a challenge. AWS still dominates the cloud for the businesses that we query. And then we see different choice of frameworks. Another thing that we didn't present here are the frameworks that are being used, whether you're developing your own environment, whether you're actually buying or purchasing pre-made models that can already perform what you need to do. And that varies between different organizations with different technical depth. So you want to consider that also on your day one environment. Will you build your own? Maybe there is something that you already can use, pay for, and just adapt to your needs. Definitely interesting. So moving on to the second part of the webinar is we talked about the compute side. We talked about the challenges, cloud, on-prem, GPUs, or which type of GPUs. What are the challenges with them, day one, day two, day three implementations. And now what we see is that there are the data management, the storage environment is sometimes an afterthought. So we see some projects where we're being called in, where there's a very nice investment on the compute environment and sometimes even on the networking environment to accommodate it. And then the storage is an afterthought. So, okay, so we just need to store the data. What we actually see is that current data management environments are ineffective in many ways. So if we're looking at the current storage market, obviously there are multiple storage architectures. There's storage area networks, network attached storage, cloud environments for capacity, object storage for on-prem capacity or cloud capacity. The thing is that all of these usually have different performance characteristics. Sometimes an organization would have multiple different solutions. So they would have SAN environments for one workload, NAS environments for another workload, object stores for a different workload, for archiving, for example. You need to manage all of these environments. You need to have different tools, different orchestration. And then in addition, it costs you more because you need to move the data between different environments. So for example, if my data arrive to my cloud environment or my object store through an IoT device, now I need to copy it to my on-prem environment, or I need to copy it to my shared environment. And is my shared environment optimized for my GPU access? Because I invested a lot of effort in setting that up, a lot of effort and money. I want to make sure that the GPUs are working at the peak of their capability. So definitely there are different layers and orchestration consideration. So to simply say it, many organizations actually, many storage environments actually forces you to choose between simplicity, speed, and scale. Choose one, choose two, but you can never have it all. And actually, if I'm looking at Weka, this is where we designed the product. So we designed the product to actually answer all of these. So to have best of performance, easy to scale, and easy to manage. And obviously, talking about orchestration, similar orchestration, you don't need to have different orchestration for a cloud and an on-prem, just orchestrate the entire environment. And we'll cover that as well. So looking at the Weka data platform, it's composed out of, and what it enables and what it's composed of, actually, multiple things. So first of all, it's composed out of the Weka NVMe flash performance tier. And actually, we have a great partnership with Supermicro, and Randy can talk about that a bit more. We actually, Weka is a software-defined environment, software-defined storage. So we don't have a storage appliance. We never sell a box. We actually sell a solution on, for example, Supermicro servers. The only requirement from the servers is actually that the servers would have NVMEs and high-speed networking between them. And then the Weka environment is installed on top of them and create that Weka flash performance tier. So it's a file system. It's a parallel file system that can accommodate for petabytes of data and terabytes of performance, as well as IOPS. And we'll talk about that as well. It also actually enables data movement between different environments, because one thing that we saw is that you never want to manage different environments, but you do want to have a way of saying, hey, I want to burst to my cloud environment, or I want to burst to another data center. So Weka can accommodate for that. There is no need for additional third-party utilities to do that. Looking at some of the environments that are being used to run on data on Weka, you can see definitely GPU accelerated environment, high performance data analytics environment, databases, and more. And the fun thing about it is that, again, I don't believe we'll get into a technical deep dive about Weka here. Definitely reach out if you really need one. But Weka can accommodate, when we're looking at performance, Weka can accommodate for massive amounts of throughput, as we mentioned, gigabytes, terabytes per second, but also, and that's the very unique thing, also for massive amounts of IOPS, low latency, and metadata. So when you look at a modern workload, you see that it's not composed out of only how many gigabytes per second does my application needs. Sometimes a modern workload would mean ingesting millions of files. That's very metadata and IOPS intensive. Going over these files or creating 0-byte files as placeholders, that's very metadata intensive. And then going over these files and building larger models from them, that would be very throughput intensive. So what we see is that modern pipelines actually are not optimized to one type of IO. They need all types of IOs. Weka can accommodate for that. So therefore, what we're saying is that with Weka, you don't need to adapt your application to the storage environment, as we've seen on the previous slide. You actually, the storage is already adapted to your application in your pipeline. Also, not less important, is that Weka supports multiple connectivity protocols. So whether it's our own POSIX client or NFS or SMB or even S3, imagine your IoT devices sending data using S3 or GPU direct storage by NVIDIA. So Weka can accommodate for all of that, and all of the data is accessible using all protocols. And again, if we look at a modern pipeline where data is ingested using NFS or SMB or S3 into a centralized system, and then that data needs to be clean and tagged, for example, by Hadoop environments. And then the data needs to be analyzed by GPU servers at a high performance fashion. So the ability to support multiple protocols to the same data, and not to different data silos, but to the same data, actually means that you don't need to manage multiple storage environments and copy the data around. And also the ability of the Weka flash tier environment to accommodate for throughput, IOPS, latency, and metadata actually means that you don't need to try to move the data to your GPU server. And that's actually, when we're looking at day one, day two implementation, that's actually a big challenge, because what we see is that multiple customers are ingesting the data to their GPU servers, running their models on it, and that's how they pilot and model their GPUs. That's nice for day one, but again, you want to think on what will happen when you grow, when you have 10 GPU servers, when you have 10 data scientists, uh, which hopefully you will, right? As you grow, you need to accommodate for that in terms of where will you store the data, how will you manage the data pipeline. So Weka can enable that as well, as mentioned. And again, we kind of like carved a few things on our flag, and simplicity, speed, and scale in all aspects. So if you could unify all of your data and orchestrate it without the need to orchestrate different data environments, if you could have best of breed performance, throughput, apps, latency, and metadata, and that's hugely differentiating. And sometimes I'm saying, if you want to remember one thing about Weka, is it that it really enables, sorry, it really enables for all of these performance characteristics. And in terms of scale, it can start with terabytes, and that's also a bit unique. Weka can start with terabytes of capacity, really giving hundreds of gigabytes of performance as well as millions of IOPS. So you can really start small and very fast, but then it can scale to petabytes and exabytes and move the data around to the cloud, to on-prem environments. And actually what we're seeing here is actually one of the main use cases. So imagine that you have your on-prem environment computing on a Weka file system, and then Weka can move the data to an on-prem object store or to a public cloud object store, and then even run on the cloud. The same Weka environment, as mentioned, that can run on the super microservers, can run on public cloud environments as well, because Weka is just software. It will run on all of these environments, providing you with backup and DR without the need to try to use any backup software. And what we see is, as data grows, obviously backup windows are shrinking, and the ability to manage millions and billions of inodes is actually shrinking. So the ability of the file system to accommodate for that is actually hugely important. So whether you want to back up in DR to another data center, create a hybrid cloud, Weka can move the data. Compute can move you. We're all familiar with containers, Kubernetes, moving containers around. This allows the data to follow the containers as well. So if I want to summarize this part, so what are the storage infrastructure requirements in the new era? So obviously architected for hybrid cloud, because we see all organizations, or as I mentioned, 95% of the organization that we talk with have some sort of cloud initiative. And again, it doesn't have to be AWS, could be multiple data centers, hybrid clouds, where you create your own data and move it around. And you want to make sure that it's orchestrated in a similar way. You want to make sure that your infrastructure will support multiple facets of performance, so low latency, high throughput, and bandwidth, and massive amounts of data. And as we saw, most of these environments, modern environments, are optimized over solid-state storage. Support for accelerated compute technologies, GPUs, IPUs, DPUs, and this is a constantly growing list. And it's really exciting to see how the market is reacting to that and how companies are innovating in that field. You want to make sure that your storage environment or your infrastructure actually would support these modern technologies in the best way, because these technologies actually mean a very heavy investment. So you want to make sure that it can be used. Mission critical availability supported by flexible data protection and rapid recovery. And I think that's a big one, because doing storage for many years, if there is one requirement for storage is to always be available, right? And you want to make sure that it's always available even throughout different failures, network failures, data center failures. That should be taken into account. And also you want to plan for the worst, where what will happen if your data center, where you placed your investment, now drops for some reason. And extreme scalability. So tens of terabytes to multi-petabytes. And again, I'll re-emphasize that. And I think if we're looking under the mantle of when you pilot an environment, when you just start with your first GPU or first investment, you want to make sure you won't necessarily buy petabytes of storage environments as you will have as you grow when you're just starting to pilot an environment. So you want to make sure that when you pilot your environment, the environment would be as similar to your end environment as possible. Uh, with Weka, that's very easy because, again, as mentioned, even with a small Weka footprint, with a double-digit terabyte environment, you get hundreds of gigabytes per second, as well as millions of IOPS. So, and that can be expanded, by the way. Obviously, that can be expanded as the system grows. So you can start with a small footprint and then double that, triple that, quadruple that as needed. Whether you're adding more storage nodes to add more flash capacity, or whether you're adding more object store capacity, and then you do it with the Weka capability of moving data between these different tiers and presenting one namespace. Actually, you're adding capacity. And ease of management, expansion of multi-generational technology and upgrades. And I think that's really important because ease of management is sometimes overlooked because with multiple storage environments, imagine how much time, effort, and money you can save if you don't need to have a dedicated team of people. I'll give you an example. One customer that we work with had 10 storage admins managing their storage environment. After they moved to a Weka environment, they actually decreased that to half a person. So it does represent an investment that now your team can work on solving the real problems and not on managing the storage that is being used to do that. Also, it represents less mistakes, ease of management, ease of use for the organization itself. And actually, I would say another thing here, expansion in multi-generational technology upgrades. So imagine that as new technologies are being introduced to the market, so for example, we also see the new AMD CPUs, the Intel CPUs, new DPUs by NVIDIA over the Bluefield NICs. So as new technologies are being introduced into the market, and by the way, also as technologies are going away from the market, for example, there are some announcements on that as well. You want to make sure that your environment is future-proof for them as well. So would you be able to use new servers as they go out into the market? Would you be able to use new CPUs technology? So for example, PCIe Gen 4 just came out. Does your storage environment support it? Obviously, there's huge advantages in doing so. So that's actually one of the strengths of software-defined storage, for example, Weka, because with new hardware going into the market, we can just accommodate for that. And infrastructure density for better efficiency. Eventually, technology is very interesting, but it's also about doing it in a cost-efficient way. And when growing into the capacities that we see a lot of customers growing, you want to make sure that your infrastructure can be very dense.
So Shimon, we have a excellent question on the chat.
Excellent.
The strategy for doing backup for up to 2 petabytes of data in a changing environment that changes more frequently than you have the ability to back it up. And I think what you just went through is a great example of how that can be accomplished, right? So you have whatever your workflow is, and you can set that up on the POSIX file system. If it's 200 terabytes, for example, you can push that data into the cloud, whether it be AWS, a private cloud, what have you. Private cloud might work well here, and move that data back and forth as it's required to and from the POSIX file system, Weka FS in this case. And that 2 petabytes of data that resides in object space can be replicated to different geos for greater protection. And all that happens at the same time. So effectively, your backup is what is in the cloud, and it can be replicated to different sites or different, like I said, different sites, different geos, or it can be replicated within the single site. Depends on your infrastructure and so forth. But it's an easy way to keep that 2 petabytes protected, but being able to bring it back into the POSIX file system, into Weka FS for anyone that needs to act on it at any point in time, and then be pushed back into the cloud.
Exactly. That's a great explanation, Randy. And I just placed here a real customer environment using a Weka environment with an object store to achieve exactly that. where the customer actually has 62 petabytes, growing to more than 100 petabytes. And that was actually their challenge as well. How do I really back it up? I never have a backup window. And they try to use multiple applications to do it. And just using Weka, which, as Randy mentioned, can expand the capacity tier between the flash environment and the object store environment, they can actually use 62 petabyte. Then the backup is actually just by doing scheduling a Weka snapshot to push the data, and then it's replicated across all the 3 data centers. That actually allows the multi-generational backup because they can do that every hour, every day, every month, and keep multiple generations. And then that also makes sure that the data is actually out of their data center. Because now, even if their data center, if their location 1 here fails, they can now just continue working on location 2. And this could also apply to a cloud environment, not just to a different multiple data center. We do have customers replicating their data, or not replicating, but sending snapshots from a Weka environment to a cloud environment, and then when needed, their backup, their restore or DR strategies to spin up Weka instances on the cloud and consume the same data. It's a great question. I hope that that we answered it. Really looking forward to more questions if we have. And I do know that we were asked a few more questions. Oh, let's see.
Yeah, we got another question on the chat.
The snapshot becomes a big, I don't know what that character means. S number, object, S3, sorry,
yeah.
That backup. That's a great question. So the answer is, how do we, or I would say the question is, when we send data to the cloud, how do we do it? Do we just send the entire file system as one big object? The answer is no, we're actually doing it in what we think is a more sophisticated way. And I'll be glad to elaborate on that also technically, so feel free to reach out to us and I'll be able to give you that technical explanation. But you can imagine that the Weka environment is pushing the data as multiple objects. Even a single file is sliced into multiple objects and placed on the object store. So there is no one big object that now is that's my backup, because that could be petabytes, right? And what do you do when you want to do multi-generational? So do you always send a petabyte? It's inefficient. It simply wouldn't work. What we do is eventually we wrote the Weka Flash parallel file system, and then we also wrote another parallel file system ourselves that now manages the distribution on the object store, and we distribute multiple files as multiple objects. Again, sometimes we're placing files together as an object. Sometimes we're taking one file and splitting it into multiple files. And then as needed, what we do when we push a snapshot, we actually just push a metadata container. So imagine that most of the data could also already be on the object store because we already periodically move the data, or there are different twists and knobs that enable that. But when we push a snapshot, the snapshot actually only is saying, hey, let's verify that all of the files that I need that describes the file system are already on the object store. Could be that they already are because we tiered them already, or it could be that we need to place a few of them. And then we just place a metadata package. And then as you mount that snapshot, you actually only mount the metadata package. So imagine that you're recovering a file system that is a petabyte file system. You don't need to wait for that petabyte to be recovered. You only need Weka to go over the metadata structures that we place there, and we can efficiently traverse, and then we present it. Now, as you access it, we go and bring the data as you access it. And then in the background, we also will go and bring the data anyway, but your RPO and your RTO are significantly reduced. What hardware, sorry, next question. What hardware platforms are recommended for classified environments?
Would you like me to handle that?
Definitely.
So that's 85% of what I do is working with the United States government and its intelligence agencies. So the way I would answer this question, it's a little bit off topic, but there are a number of hardware vendors, obviously, and we're moving towards certification of that hardware. One thing that is really important to know with Weka is it provides encryption. It provides encryption on the wire, provides encryption at rest. So the hardware that's provided obviously is going to need to meet different criteria, SP 800-147 and 193. A lot of the Supermicro hardware using the brand new Ice Lake platforms and Milan platforms with AMD as well can meet those requirements. And Weka has the ability to provide the encryption for the files in the file system and on the wire, as I mentioned before. So having a hardware platform that can meet the root of trust capabilities and the certifications that are required for that type of an environment, along with the encryption capabilities of Weka FS, I think can create a very good solution for classified environments. And I would highly recommend that you take a look at them.
Excellent. Thanks for that, Randy. Another question, is it possible to have Weka clients access the Weka storage nodes from multiple VLANs to avoid the need for high-speed firewalls? Definitely. Yes, you are able to do that. I'll be able to elaborate as needed. So the Weka, there's a lot of things that we didn't mention on the Weka platform here. We mentioned the speed, the scalability. Randy just discussed the security a bit. There are multiple other features. There are multi-tenancy environments, so you can make sure that you're creating multi-tenant environment where each of the tenants can only work with their data and manage their data. They are not able to manage and touch other data. VLANs is one part of it. So I'll be able. So feel free to email us, and I'll be able to elaborate on how we do that. I think, yeah, we're good on time. We still have a few minutes. If there are any other questions, I'll be glad to take them.
Shimon, in the chat window, the question comes up about having a copy of the slides made available.
Definitely. So we recorded this session. Just need to make sure that we have your details so we can send you the presentation. And I do see other questions that we're usually being asked. So if you have a few minutes, I'll answer them as well. So one of the questions that we are commonly encountering is being software defined, just running on off-the-shelf servers. So imagine the Supermicro servers that we're running on. These are just off-the-shelf servers with NVMEs. There's no RAID controller, no RAID array, no JBOD, no JBUF. We really simplify the environment. So a lot of the questions are around how do we provide resiliency? How do we make sure that even when there's a hardware failure, all of the data is still available, even if there's a data center failure? So the answer is that since we wrote all of that data environment, we didn't rely on any other solution like hardware or software like we see other storage platforms are doing. We are able to do that. So with Weka, imagine running on any amount of servers, failing a few servers, Weka is already able to rebuild from that data. So when you fail multiple servers, the data is still available because we erasure code the data across multiple servers. And we have a lot of actually patents on how we do that in an efficient way. And then on how we continue writing on the graded stripes. And then as data drops, as servers drops, could be a server with 10 NVMEs, 150 terabytes, doesn't matter. Weka erasure coded the data across multiple servers. The data is still available, and it's even more, it's still available in the same performance, because we want to make sure that storage or this storage is not only performant, but it's predictably performant. So one thing that we see, and that's very important, we see in financial environments, but also I imagine in healthcare and other environments, is that when you have a failure, you need to maintain performance. You can't go into a degraded mode where suddenly everything halts. And we can guarantee that because we wrote all of the data layers, whether the data is going between the storage, between a client to multiple virtual metadata servers, whether it's going from the metadata servers that are split across all of the environment for high performance to the data nodes themselves across our internal NVMe fabric. So we can guarantee that while and the environment have a challenge with that. So whether it's, by the way, the entire data center, if the data center drops, we can still guarantee that when you go up, the data will just be available. Every IO that was acknowledged is still available. There is there's no loss of access, but by the way, there's also no FSDK process. Imagine, and I know that's a challenge with multiple petabyte scale file systems, is when you drop after a power outage or a drop of the storage, when it goes back up, you're waiting for like hours or days for the FSDK process to complete. With Weka, by design, we eliminated that need. And again, I'll be glad to elaborate when needed. So the storage would just go back up in seconds. And again, and another question that we're usually being asked is, and I'll reluctantly answer because maybe some of you are thinking it, is how is the solution priced? So the solution is priced. Obviously, Weka being software, there's the software pricing, and then it's running on commodity hardware. So the solution is priced according to usable capacity, which can always, by the way, expand as well. So maybe on day one, implementation includes a few terabytes, and then you expand, that you can just add to that. It's aggressively priced because we do see that cost of ownership is as important as the technology itself. So you don't want to use Weka only for the high performance, small scale. With the Weka capability of expanding over the flash tier and over to the object storage tier, as well as moving the data and enabling that capacity, you now have a very efficient TCO on your performance and capacity tier. And we actually just came up with a few very interesting bundles with Supermicro, making it very attractive. So actually, you see the Supermicro email. If that's interesting, Supermicro is already able to just send you SKUs of an entire solution. So you don't need, it's not a science project. So you don't need to buy the storage and buy the software and do it yourself. That's what we have our partners for. So you get a complete solution and a complete ownership of that entire solution. And I think with that, we're spot on time. So if there's any last questions, I'll be glad to answer. If not, really feel free to email us at info@weka.io or to wekapm@supermicro. We'll be glad to elaborate more. So thank you very much. Thank you, Randy, for attending with me.
Thank you.
And have a great day.